Alright, so we talked a little bit about quadratics, what the graphs look like, how to graph them. We also talked about the different forms, the standard form and the vertex form. And so now we're going to go over that in a little more detail. And first we're going to start off with a simple problem that you may see on a test. We're given a problem, f of x, given an equation, excuse me, equals x squared plus 2x minus 3. And we're asked, does this graph have a minimum or a maximum value? And then it says, find the coordinates of the minimum or maximum point. So, if you remember towards the end of the last video, if you stuck it out that long, we talked about this briefly, but we'll go over it again very quickly. In this standard form here of a quadratic, you have you have the coordinate of the x squared term signified as a. You have the coordinate of the x term signified as b, and then your constant is c. So, if your a is greater than 0, then your graph is going to curve up. It's going to open up like this. If your a is less than 0, it's going to curve down like this. It's going to open down like this. So in this problem, in this equation, x squared plus 2x minus 3, a is equal to 1. So your graph is going to open up, which means you're going to have a minimum at the vertex. At this point right here, you're going to have a minimum. So when they're asked, does it have a minimum or a maximum value, it's going to have a minimum. So find the coordinates of the minimum or maximum point. Well, in a standard form like this, if you remember, the value of h is equal to negative b over 2a. So b is negative 2. And then your a coordinate, your a is 1. So it's equal to negative 2 over 2, which is negative 1. So your axis of symmetry is going to be through the line x equals negative 1. Now, to find k, all we do is evaluate this function at that h value. So f of negative 1, you get negative 1 squared plus 2 times the negative 1 minus 3. So negative 1 squared is 1. 1 minus a negative 2 minus 3. So 1 minus 5, that's negative 4. So the coordinates of the minimum point is negative 1 and negative 4. So we'll look at we'll show the graph here so you can see what that looks like. There it is. There's our minimum point at negative 1 and negative 4. So that's all we have to do to find whether it's a minimum or a maximum. We look at the a in the standard form, and then we find what, if we want to find that actual point, and we look at it from negative 1 and negative 4. Now, if this were in vertex form, a little bit different, and we'll go back to the problem that we did in the earlier video. We'll say f of x equals 4 minus x minus 1 squared. And if we have it in vertex form, we already know what our vertex is going to be. All we have to do is look at it. So remember, the vertex form of the equation is a times x minus h squared plus k. So here, that's your h, that's your k, and your a is out here. And since this is a negative, your a would be a negative 1. So if you're given in vertex form, it's just like, okay, well, the vertex is at 1 and 4. Remember, because this is x minus h, so if you have it as x minus 1, then that's going to be a positive 1. So your vertex is at 1 and 4, and our a is a negative 1 because we have this negative out here. So a is negative 1, so that's going to be a maximum at the point 1 and 4. Now if we're given, suppose there's a problem that we're given, and we'll use the one that we just did, and we're given a quadratic f of x equals 4 minus x minus 1 squared. And we're told convert this to standard form. It's literally as easy as just multiplying this out and collecting like terms. So if we want to go from vertex to standard, all we have to do is say, okay, this equation equals 4 minus x minus 1 times x minus 1, because that's x minus 1 squared. And then we can do our FOIL. So we say 4 minus x squared minus x, so that's minus 2x, plus 1. So that equals 4 minus x squared plus 2x minus 1. So then in standard form we would have negative x squared plus 2x, 4 minus 1 is 3, so plus 3. And that's how we go from vertex form to standard form. We just multiply it out. Now the opposite, going from standard form to vertex form, is a little trickier, but I'll show you an example and hopefully be able to figure it out after this example. So if we have, and we'll use the problem that we just did, if we have f of x equals x squared plus 2x minus 3, and we're given a problem, go from standard to vertex. Well, the way that we have to do that is we have to do something that's called completing the square of a quadratic. And that may sound familiar to you, it might not be, but we'll work one out here and hopefully it'll make sense. So the first part of completing a square is saying, okay, you collect your x terms. So x squared plus 2x. And then we'll put brackets, or we'll put parentheses around them. And then, just to show that we're grouping them together, and then we'll have our minus 3 out here. All right, to complete the square, we want to look at what we would need to add to this group here to make it a square term. Well, if you remember from factoring, if we x squared plus 2x plus 1 is what we need. We would take this this term here, basically, and divide it by 2 to find out what this would, and then multiply that number to find out what this number would be. Well, 2 divided by 2 is 1, and 1 squared is 1. So we just add a 1 here. And then we leave this 3 out here. All right. So now we can express this term here inside the parentheses as a square term. That's x plus 1 squared. But since we added 1 here, we also have to we have to add the opposite of that here to make sure that we don't change the value of our equation. We're adding 1 here. We have to subtract 1 here to keep the overall value the same. So we get x plus 1 squared minus 4. So that would be the vertex form of that same thing, of that same equation. We complete the square, and then we group them together. So our overall answer would be the same. Our vertex would be the same. It'd be -1 and -4, but we're just expressing it in a different way. Let's do another one here just to make sure that it makes sense. So we'll do the second problem that we did in the last video. We'll do, actually that's too similar here. Let me see if I can find a different one. All right, we'll do this one. F of x equals x squared plus 6x plus 8. And we'll be asked, we're going to convert this from standard form to vertex form. All right, so the first thing we do is we'll group these x terms together. X squared plus 6x plus 8. All we're doing is grouping them together. All right. Now, in order to complete the square, we're going to look at this x term here, divide it by 2, and then square that answer. So 6 divided by 2 is 3. 3 squared, I'll go ahead and write this out here. 6 divided by 2 equals 3. 3 squared equals 9. So that's what we're going to add to our parentheses term here to complete that square. Say x squared plus 6x plus 9 and plus 8. Now, because we added 9 here inside the parentheses, we'll have to subtract 9 here to make sure our equation is balanced. So, this -9 cancels out with this +9. So now we can complete this square and write this term inside the parentheses as x plus 3 squared plus 8 minus 9 is a -1. So that's how we would express this equation. We would go from standard form to the vertex form. And here we can see that the vertex would be at the point -3, -1. So going from the standard form to the vertex form is a little bit trickier because we have to complete the square. But hopefully that makes it a little bit clearer. And if that is something that comes up in the future, you'll be able to know how to solve it.